Okay, so here's another neat application. This one's from chemistry. I don't know, chemistry, neat, right? Well, chemistry can be actually sort of interesting in that when we talk about these particular applications, we very often use logarithms, especially when we have to deal with very, very large or very, very small numbers that are typically written in scientific notation form. And here's one. This is called a solution that contains the hydronium ion. So a hydronium ion is a positive hydrogen ion that doesn't have an electron. And so we say the concentration of these, this is a kind of pH, is given as the negative logarithm of that hydrogen ion concentration in moles per liter. So, for example, let's say we're told to find the pH of a solution with a hydronium ion concentration of 5.77 times 10 to the negative 6 moles per liter. What do? Well, we'll work it out. Let's go ahead and put in our numbers. We will be taking the pH. Let me get my marker working here. The pH level to be equal to the negative of the common logarithm of this number right here. We would put in 5.77 times 10 to the negative 6. So what will we get? Well, you notice that negative number out there, so I'm going to put the negative out there, and I'm going to say it's the negative of the logarithm of 5.77 plus the logarithm of 10 to the negative 6. Well, we know what happens there again, right? Because of this logarithm base 10 to the negative 6 common logarithm, the 10 and the natural logarithm cancel each other, so we'd be taking the negative of whatever we get by adding the logarithm of 5.77 and then subtracting 6 from that value. I should say 5.77, and hopefully my marker actually begins to work one of these days. 5.77, darn leaky marker. And what happens here? Well, let's work it out. Here's my, whoops, that's not what I wanted. That's some orange juice. Oh, let's go back to the board here. There we go. I was thinking about breakfast this morning. Okay, so let's take this. Let's take 5.77, take its logarithm, and then subtract 6 from that. And there it is, negative 5.2388. So let's round that, negative 5.2, right? And we're going to say that we're taking the negative of negative 5.2, so that is 5.2 as our pH. And on the pH scale, whatever we're looking at, looks like we're down here in about this area right here. Maybe we're talking about cooked beans, chicken, or beer. This would be the pH level of that particular solution. Well, how about some other solutions? Here's some interesting ones. Orange juice happens to have a hydronium concentration of 2.8 to the negative 4 moles per liter, right? This one was slightly acidic. Wouldn't orange juice be slightly acidic? Well, let's find out. Let's take our logarithm right here. I'm going to take my common logarithm. Here's my OJ. I'm going to take the negative of my logarithm of that value, 2.8, times 10 to the negative 4th moles per liter. That will be the same as taking the negative of the difference of the logarithm of 2.8 minus 4. That's what's been happening. So when we rewrite this, of course, I'm going to take my logarithm of 2.8. Let's clear this. 2.8, hit logarithm, subtract from that 4, and then take the negative of that number. And here is my logarithm, 3.55. So my logarithm is 3.5 or 3.6, let's say, 3.6. Oh boy, that's actually getting down here about somewhere in this acidic pH level. So OJ is probably right down there with just below coffee and white bread and beef, shellfish pastries, juices, and that kind of stuff. Fruit juices, actually, a lot of fruit juices are that, but I don't know that this goes in any particular order. How about milk of magnesia? What is milk of magnesia? Well, people sometimes take this as a medicine to prevent cramps. What kind of thing have we got right here? Well, let's put that milk of magnesia right here. See what's going to happen. Well, in this case, let's take our negative logarithm of the quantity 3.97 times 10 to the negative 11th and see what's going to happen when we work out this value. We'd be taking the negative of the logarithm of the number 3.97 and subtracting from that 11. That should be an 11 up here for whatever reason. It doesn't quite look like it. It looks more like an N here. Now it looks like an H. Leaky markers, the bane of Professor Peoples' existence right here. Negative 11. There we go. Okay, so what do we come up with? Well, let's break out the old calculator one more time. 3.97. Take the logarithm of that. Subtract 11 from that number. We've got negative 10.4, and we're going to take the negative of that. So our answer right here is 10.4. So that definitely places us in the alkaline region of our pH scale, somewhere way up here, right? 10.4. And so that's a pretty high alkaline solution. Okay, good luck on your homework. I'll show a proofs video as just an added extra at the end of all of this. See you in class.